An alternative to substitution method is actually called the elimination method. And if you remember from our topic in the fall semester, we need to either find or create zero pairs so we can cancel some quantities out. The zero pairs mean same variable, same coefficient, but opposite signs. So if you look at the left-hand side, we can easily eliminate y by multiplying the left-hand side by -1, right? So if you multiply y by negative, you have to do it for all of them. It's -1. So that means the first equation will stay the same. And as you rewrite the second equation, since we're multiplying it by -1, try to line up, like terms as well. Like this is -2x, base it under 2x. And then negative times negative will become positive. So if we add these two equations, these two will cancel out. That turns to 0 equals, you bring down your x squared. Now 2x minus 2x will also be 0. And then this one is negative 4. There you go. So now does this look familiar? This is a quadratic equation of the form x squared is equal to d, right? So if you move your 4 here, you'll have 4 is equal to x squared. So you remember what we learned about how to solve equations that look like this? You get the square root of both sides, so x will be equal to plus or minus 2. So what we need to do now is substitute these values of x so we can find the corresponding values for y. So if we substitute positive 2 here, you'll get 2 squared plus 4 plus another 4 is 8 minus 5, so 3. So that means when x is equal to 2, y is 3. You can do the same thing here. That's 4 together, take away 1, that's 3. Now let's substitute the negative 2. So that would still be 4 minus 4. That would be 0, negative 5. So when x is negative 2, you get negative 5. If you do it here, 2 times negative 2 is negative 4 minus 1 is also negative 5. So that means the solutions are 2, 3, and negative 2, negative 5. So that's one example using elimination method. Is it possible for two equations to not have solutions at all? So let's see what we have here. Again, you can keep the first equation, just like what we did in the previous example. And if you want to eliminate the y, you can multiply equation 2 by -1. So that means it will become negative y is equal to positive 3x. Again, let me line up similar terms. So 3x plus 8. So this will cancel out. We'll get 0 equals x squared. This will also cancel out. And then you have plus 6. So this is again a quadratic equation of the form x squared is equal to d. But if you square, and like either a negative or a positive quantity, the result has to be negative. In other words, you can't get the square root of a negative constant. So this is not possible. And not possible. Well, at least in algebra 1. So that means this system of equation has no solution. Well, if you double check our answer by graphing, how do their graphs look like? Well, let's see. Okay, so I have here the graphs of the two equations that we solved by using the elimination method. And as you can see that, by using decimals, we can clearly conclude that our answers were correct because the two graphs do not actually intersect. So that means, they don't have a solution because they don't have common points.